So, coterminal angles. By defining angles in terms of their rotation, two angles can have the same initial side and the same terminal sides, but different angle measures. These are called your coterminal angles. Okay? So say you have an angle that lies in standard position. Real quick review. Standard position means what? What's that? What do you mean, Caleb? What is that?
It's going down.
I think I follow it. Come in. Let's add a little bit to that. Alex, what you got?
The vertex is at the origin.
Vertex at the origin. Okay? And that, yes, from the very front side of your notes. The initial side is located where? To the east, on the positive x-axis. The initial side never moves. Okay, so that's what you meant by that? Yes, that initial side never moves. The terminal side is the side that can move. It can go round and round and round. Okay? So, when you have an angle that's in standard position, okay, such as this one right here. Again, remember my board is a little off, okay? So just let me know if I need to go to the board. Okay? Now, to get 60 degrees, you go from your initial side to your terminal side, and there it is. There's that 60 degrees, okay? But you can have the same initial side and the same terminal side, but a different angle measure, and that's represented by continuing circles, okay? Do you see this right here? This one, to this one, to this. How many times did I go around? I went around 2 full revolutions, okay? How many degrees are in 1 full revolution? 360. So if I went around twice, how many degrees is that? 720. So I went around 720 degrees plus an additional 60 to make a total of what? 780. That's where that 780 is coming from. That's an example of a coterminal angle, okay? Same initial side, same terminal side. I just went around more than once. Yes? All right? Now you can also go in the negative direction, okay? Remember, if you go counterclockwise, it's a positive angle. Counterclockwise is a negative angle. So, if I went from my initial side in the clockwise direction, and still ended at my terminal, how would I be able to get a negative 300 degrees? I'm going clockwise. So where would the negative 300 come from? 360 minus 60, and then?
Well, 60 minus 300, right? I mean, 360 minus 300.
Because it's on the negative side.
Because it's on the negative side, so you just know to just do 360 minus 60 and add a negative to it. Okay? You could also do 60 minus 360. You could do that way. Okay? And that way you don't have to remember about putting in the negative. And the other picture drawn there for you is just an example, except using radian. Okay? Questions about the coterminal angles? So, any angle has indefinitely many coterminal angles found by adding or subtracting integer multiples of 360 or 2 pi. So, 360 is when you're dealing with degrees. So, if alpha, okay, that A, that's called alpha, is the degree measure of an angle, then all angles measuring alpha plus 360 in degrees, where n is an integer, are coterminal with alpha. Meaning, whatever alpha is, it could be 60 degrees, it could be 100 degrees. If you continuously add 360 degrees, or multiples of 360 degrees, or subtract multiples of 360 degrees, you'll have a coterminal angle. Okay? And the same thing happens with radians, except this time you're adding 2 in pi. Okay? Because think about it. 360 degrees is 2 pi radians. So you would add multiples of 2 pi or subtract multiples of 2 pi. Okay? Questions?
No.
Okay. So if alpha is a degree measure of any angle, give me any degree measure.
220.
Okay? Now, 220 degrees. I need an angle. I need an initial side and I need a terminal side. Okay? Where's the initial side located?
Towards the east.
Towards the east on what? On the x-axis?
On the x-axis.
So you have this initial side here and 220 degrees. That's the angle he gave me. Where would that be located? Would that be located in this, here? Which area? Left bottom. What quadrant is that? Review of quadrants. Three. That's the first, the second, third quadrant, fourth quadrant. Okay? So 220 would be here. Okay? There's your initial side, 220 degrees. Now, all the angles measuring alpha plus 360 n, where n is an integer, are coterminal with alpha. Somebody give me a value for n. 3. Okay? So if I do alpha, which is 220, plus 360 n, which is 3, what's 360 times 3? No. 1,080. So you have 220 plus 1,080, which is 1,300 degrees. That right there is a coterminal angle to 220. So that basically means that if I were traveling in a positive direction from that initial side, 1,300 degrees. There's 360, 270, 1080, and the final 220 degrees. That right there is a coterminal angle, and that's how you would draw it.
What are coterminals like represent?
They represent basically 220 degrees, 1,300 degrees, 580 degrees. They're all going to have the same value. Okay, so it doesn't matter what the angle is. If I ever ask you to find the sine of 220 degrees or cosine of 220 degrees or 1,300 degrees, if you know 220, you'll be able to know 1,300 as well. Okay? They are going to be the same. It doesn't matter. It just has multiple revolutions. It still has the same initial side and the same terminal side. Yes. Well, it doesn't matter what n is. It could be any multiple. So n could be any integer. It could be positive or negative. I had somebody give me 1, so they gave me 3. That's why I went around as many times as I did. I went around 3 full revolutions, and then I ended at 220 degrees. Other questions? And it also works for radian. You guys good? Okay. Well, let's see. You are going to be doing this yourself, okay? You have 80 degrees and negative pi over 4. And you're going to identify all angles that are coterminal with the given angle. Then find and draw one positive and one negative coterminal with the given angle. Okay? So how would I identify all of the coterminal angles? What would I do? All of them. What's the way to represent all of the coterminal angles? Okay, so what would it be? For 80 degrees, what would it be?
80 plus 360.
This right here is how you identify all the angles that are coterminal to 80 degrees. Because it doesn't matter what n is. N could be positive, n could be negative, any integer. When you multiply by 360 and add it to 80, you will get a coterminal angle no matter what. That's how you represent all of them.
So you just write down the thing.
Huh? That would be coterminal to 80. Like it has to be a multiple 360 and then you have to add 80 to it. So no matter which way, we're never going to get 300. Now we could get negative 280. That would be coterminal. Okay? You have to then find and draw one positive and one negative angle coterminal to the given. Okay? Easiest way to do that, pick a value for n, like we just did on the other example. 1. That would be nice. Okay? Make n 1. So, what is 80 plus 360?
440.
440. That is a positive coterminal angle. I'm going to draw in just a second. Let's get the negative one. So I'm going to plug in a negative 1 for n. So what is 180 minus 360? Here's another coterminal angle. Now you could do 1, negative 1. You could do 2, negative 2. You could do whichever one, but the thing is that when you draw it, you need to make sure that you draw it correctly. So, 440. Okay? First off, 80 degrees, where's it located?
First
quadrant.
quadrant.
First quadrant. Okay? So there's my terminal side. Should line up with the origin. Now, for 440 degrees, I have to go one full revolution and then 80 more degrees. So I start on my initial side, I go around one time, and then I end at 80 degrees. And there's my positive coterminal angle. Remember, positive always goes counterclockwise. All right? Negative, which way am I going to go? Clockwise. Where do I start? Where? And where's the initial side? To the east. It's along your positive x-axis. So I still have that 80-degree angle, except I start here.
Where do you start?
On the x-axis, on the initial side, which is always on your x-axis. And you go clockwise. And there's negative 280 degrees.
But it doesn't look like a full rotation.
But see, negative 280 isn't a full rotation. If it was a full rotation, it would be bigger than what number? 360. So that's why it doesn't go all the way around. It only goes almost that. Definitely more than 270, but not as much as 360. Okay? You guys try the next two on your own. Try the next two on your own. Oh, I just realized. Didn't do the radian one on the other page because I went into the notes. So I want you to do the 3, okay? I want you to do all 3 of these. For the radian, if you can't figure out where it is, maybe convert it to degrees, and then that can kind of help you where negative pi over 4 should be located. Okay?
What are you talking about?
I'm talking about B. We didn't do B?
Yeah.
So I want you guys to do B as well. Yes. Okay. So, negative pi over 4. Where is that located? It's located negative 45 degrees. So what quadrant is that? It's the 4th, okay? So, you're going to be right in here. There's your terminal side. There's your initial side, okay? So, to identify all the angles that are coterminal with the negative pi over 4, it's just going to be negative pi over 4 plus what?
2 pi.
2 and pi. Okay? That is how you identify all the coterminal angles. Now to get a positive one, a positive coterminal angle, I just need to plug in a value for n, a positive value for n, such as 1. So you'll have a negative pi over 4 plus a 2 pi. Now this is nothing but adding a fraction to a whole number. In order to add fractions, you need a what? Which would be 4. So this is the same thing as saying negative pi over 4 plus 8 pi over 4. Now when I add those, now that I have a common denominator, what's negative pi over 4 plus 8 pi over 4? And that would be one of your coterminal angles. Positive. I start in my initial side and go which direction? Counterclockwise. So right here, that would represent 7 pi over 4. If I did another value for n, such as 2, I would have to go around one more time and end right back there at my terminal side. What value you want to plug in for n to get a negative angle? Negative 1. So that's a negative pi minus a 2 pi. Because when I plug in a negative 1 for n, that ends up turning into a minus 2 pi. So instead of adding 8 pi over 4, I'm going to subtract. And what value do you get?
Negative
Over 4. Now you do have to keep it with radians because if they give you a radian to start with, you have to keep it as a radian. Okay? Or all your answers should be radians. Alright? So I have my initial side on my x-axis, my terminal side in the fourth quadrant. To get a negative angle, I'm going counter or clockwise? Clockwise. From your initial side, I go around one full time, and then another power 4. There you go. Questions?
So it doesn't work. Just
If you turn it into a degree, you would have to turn it back into a radian. Yes?
Do you ever start your rotation at the terminal side?
No. It will always start from your initial. Always from that positive x-axis. Negative 30 degrees, where's it located? Careful, quadrant 4. Okay? So there's your terminal side, there's your initial side. What is a positive coterminal angle? 330. That's an example. So if I start at my initial side, I just go around and end at my terminal side. What's the negative coterminal angle? You get that by plugging in a positive 1 and a negative 1 for n, I'm guessing. And yes, there's nothing wrong with using positive 1 and negative 1 every single time. Now, if it asks you for more than one negative angle or more than one positive angle, you're going to have to keep adding. Okay? Start at my initial. Clockwise or counter?
clockwise.
What's my general formula?
The angle plus 360.
360 what?
And
N. Questions? Over here, it's going to be the same as the other one, 2n pi for my general equation. So somebody give me a positive coterminal angle. 11 pi over 4. And a negative 1. Where is 3 pi over 4 located? A quadrant. Careful. Second. So 11 pi over 4, I start on my initial, I go clockwise, one rotation. Remember, 2 pi is 360 degrees, so one time all the way
How
around.
did you know the 11 pi over 4 was at that point? You converted to degrees?
Is that what you guys did to figure out where 3 pi over 4 was located?
You converted what?
Converted to degrees to figure out where it was located? After Monday, hopefully we won't have to worry about any converting. You just know.
Yeah. One half.
That's what the shoulders are.
Yeah. I could have listened to rights to you, so I could have listened
And there you go. There's the other coterminal angle. Questions? All right, well, let's see. Your whiteboards. Applications. If theta is a central angle in a circle of radius r, then the length of the intercepted arc is given by S equals r theta, where theta is measured in radians. So that angle is not a degree, but a radian, okay? And that intercepted arc is basically part of that circumference, okay? Where the radii basically cut into the circumference. This is how you find the length of an arc, that formula, S equals R theta. Yes,
What is S representative of?
the length of an arc. That nature. It's pretty simple. You follow the formula, okay? So when it says find the length of the intercepted arc in a circle with a central angle measure of pi over 3 and a radius of 4 inches. When you're looking for the length of the intercepted arc, they want to actually know that part of the circumference, okay? So you use that formula that you should have written down on the other slide, which is S equals R theta, where theta is measured in what? Radians. If that angle measure is not in radians, you have to put it in radians, okay? What's my radius?
Over 3.
Yeah, the radius is 4, and our angle measure is pi over 3. Since we're rounding to the nearest 10, we go ahead and we type in 4 times pi over 3 to get our answer. Rounding to the nearest 10. What does S stand for? The length of what? The arc. Nearest 10, what did you get? 4.2. And we need our units here. We're talking about length. So this is 4.2 degrees? Inches. Okay, we are talking about a length here. Okay? You always make sure that your angle is in radians. It's so good. When you turn it on and you're shutting off when you then you let me. Okay? Look at example B. Find the length of the intercepted arc in a circle with a central angle measure of 125 degrees and a radius of 7 centimeters. Round to the nearest 10. You're looking for length, so you need that formula again. But why is this one different from the other one? This has to be in radians. So how do I convert that degree to a radian? Pi over 180. And what is that? 45 over 6?
25 over 16.
25 pi over 16. No. 36. Oh, you say 36?
I don't know. I put it in my calculator.
Okay? So there is your angle. So I plug in 7 for my radius, 25 pi over 36 to get my arc length. If I try to plug in 125 degrees, I'm going to get something that's completely different. And rounding to the nearest 10, what is the length of my arc? Can I get a second? Good stuff. Okay? Whiteboards. Arc length is used to analyze circular motion. The rate at which an object moves along a circular path is called its linear speed. A lot of times it's measured in miles per hour. The rate at which an object rotates about a fixed point is called its angular speed, represented as revolutions per minute. Now, if S is the arc length traveled by an object during time t, then the object's linear speed, v, is given by that equation, S over t. So to find your linear speed is that formula v equals S over t, where v equals your linear speed, S equals your arc length, and t representing your time.
Can you repeat that one more time?
Yes. The object's linear speed is represented by v. S is your arc length. And we just did a few problems on how to find arc length, so that shouldn't be anything too challenging. And then t is your time. So to find your linear speed is v equals s divided by t. Now if theta is the angle rotation, of course measured in radians, through which an object moves during time t, okay? So how it rotates, how it moves. Angular speed of the object is given by W equals theta over t. Or again, theta is your angle of rotation and t is your time. Now that W, that is the lowercase letter for the Greek alphabet of omega, okay? So just like that interesting looking A when we were doing coterminal angles that represented alpha, this here, this W looking symbol is actually omega, okay? So those are your formulas to find linear speed and angular speed. All right? So we're gonna look at some examples involving angular speed and linear speed. Okay. So a typical vinyl record has a diameter of 30 centimeters. When played on a turntable, the record spins at 33 1/3 revolutions per minute. Find the angular speed in radian per minute if the record as it plays, rounds to the nearest 10, and then find the linear speed at the outer edge of the record as it spins in centimeters per second. Okay? Angular speed. What's the formula for angular speed? Omega equals theta over t, where theta represents what? Angle of rotation. Okay? Well, that angle, how do you figure we're gonna figure that out? How do you think we're gonna figure that out?
Plug it in.
Plug in what? So you're saying 33 1/3 represents theta? That's revolutions per minute.
So just take the 1/3 and see 1/3 of the 360 degrees. That's our angle.
Well, not just the 1/3. It will be all of it together, the 33 and the 1/3. Okay, revolutions per minute. Okay,
So we were looking for 60.
it's going around 33 1/3 times in 1 minute. Okay,
360 times 33 1/3.
close. It's measured in radians, so not 360, but
2 pi.
2 pi. So to find theta, you are going to take your revolutions per minute and you're going to multiply that by 2 pi to get the actual angle, because it's going around that many times in 1 minute. So to figure out what that angle is, you multiply that by 2 pi.
Why are you doing it by 2 pi?
Because since it has to be in radians, instead of doing 360, you do the radian equivalent, which is 2 pi. 2 pi radians is 360 degrees. Take a look at it. So if it's radians, you have to use the 2 pi, not the 360. Now t, what is t? Time. What's the time here? 1 minute. So that's easy. It's just 1. So we're going to take this theta and divide it by our time, which equals 1, to get our angular speed, which is lowercase w looking thing. What you guys get?
Would you make 33 expand it out, or?
You could do 33.3, or you could do 1 divided by 3 times 33 times 2 pi, or 100 over 3.
209.439512.
So to the nearest 10, that would be 209.4 radians per minute. And that is our angular speed.
Okay, and we got the 2 pi from the previous thing of notes?
Yes, because we have to make sure that it's in radians. So we have to multiply the number of revolutions by 2 pi to figure out the actual angle measure.
I thought like the radians and the degrees was like 180 over pi or pi equal 180.
That's how you would convert if you were given a radian or if you're given a degree to get to that, but we weren't given neither. We were just given the number of times that this vinyl is turning. And so we would take that, the number of revolutions, and multiply it by 2 pi to represent exactly what that angle is as it's going around 333 in the third time. It would have been, yeah. All right, so to find your linear speed, what's the formula for linear speed?
Equals S over T.
S over T, where S represents your what? Arc length. We just figured out how to do arc length on the other problems. What's arc length's formula? Times theta. Now we already know what theta is because we used to define our angular speed. So we take that 33 1/3 times 2 pi and multiply it by our radius, which is what? 15. How'd you get 15?
Half 30.
Half of 30. I'm going to finish off this problem, and I will post the rest of the video up. Please make sure you guys watch it, okay?
Yeah.
You guys do have a homework assignment, so please do. All right, so where we left off in class, we were finding the linear speed. We determined that S, which is our arc length, is our radius times our angle, which we found in part A through our linear speed. And so to find our arc length, we're going to multiply our radius by theta. And then we are going to divide that by our time. And so what we can do here is we can first just divide it by 1. Goes. And when we multiply all this together, we'll end up getting 1,000 times pi over 1. Now I don't have calculator on me, so I'm just going to leave it for right now in terms of pi. So we have 1,000 pi over 1, and that represents centimeters per minute for my linear speed. Now, it doesn't ask me for centimeters per minute, it asks me centimeters per second. So what I'm going to have to do is I'm going to have to take this fraction here and convert it to seconds. And to do that, all you do is multiply that by 1 over 60. And that will give us our minutes per second. I'm going to go and grab a calculator and do this real quick. And so when I divide here, I'm going to end up getting 52.4 centimeters per second. Okay? All right, hopefully that made sense. If not, make sure you bring your questions to class. Now, to finish up the lesson, the area A of a sector of a circle with the radius r and central angle theta is given by the formula A equals 1/2 r squared theta, where theta is measured in radians and r, of course, is your radius. And it's pretty simple. It's pretty straightforward. Make sure that theta is in radian. Plug it into the formula. So to find the area of this sector, we are going to take our radius, which is 5, and we're going to square it. So 5 squared is 25. And then we're going to multiply that by our radian measure. Since it's already given to us in radians, it's going to be 3 pi over 4. And then we're going to divide all of that by 2. And that's how we're going to figure out what our area of our sector is. So we're going to go ahead and grab our calculator. We're going to type this in, and then we're going to get our answer, rounding to 3 significant figures since it doesn't tell us exactly how to round. And that's going to be 29.5 meters per second because we are dealing with area. Take a look at the next problem. I want you to try it on your own. Pause the video and do that. Alright, so hopefully you remember that you had to convert the degrees to radian. So you should have got pi over 3 radians for the
the angle measure. You do 1/2 times 8 squared, the radius squared, times the angle measure, which is pi over 3, rounding to 3 significant figures to get 33.5 feet squared. Okay, so guys, make sure you do your homework. I'll see you guys on Friday. And please bring your questions then.